Hello and welcome to Chapter 3, Section 2. So even though this is Section 2, this will be the final section we discuss over this chapter. So get ready for some review as we get further along this week. But for today, 3.2 is about solving our linear equations. By this time, we're focusing on graphing. So we'll look at those in some examples. So, first one up today. Example 1 tells us to solve the equation. Now we're given some terms on the left and some terms on the right, and we need to find a way to solve it. So the first step that we're going to do to solve these problems is to get everything on one side of the equal sign and set it equal to 0. So how about we just try to move everything to the left, set it equal to 0, and then we'll go from there. So, if I rewrite my equation, I have 2x minus 5, that's equal to negative 3 plus 2x. Good. Now I know my first step is to move everything to the left. So, this 2x over here I don't want, so I'll subtract 2x from both sides. So if I switch colors, subtract 2x. We have to do it to both sides, as we see. So this goes away, but this also goes away because 2 and 2 cancels out. So what are we left with? Well, with that step, we have a minus 5. That's equal to negative 3. And if I now want to continue to move everything to the left, so let's see, I could add 3 to both sides. This becomes a 0, and this becomes negative 2. So negative 2 equals 0. Now the second step, once we have whatever's on the left equal to 0, we replace the 0 with f of x. So we can rewrite this as negative 2 equals f of x. Now f of x is the same thing as y, so you can think of that as y. That is just our function. So f of x equals negative 2. Now we can graph that, and we know y equals negative 2, or f of x equals negative 2. We said that those are flat lines, so that would be a flat line along negative 2 on our graph. So imagine that line is perfectly straight, we'd have that. Now when we're looking to solve our equation, we want to find, when we graph our line, what value, at what point does it cross the x-axis? That would be the solution to the original equation that we had. So where does this line cross the x-axis? If you're confused by that, the answer is it doesn't. It never does. So the answer to this first example, there is none. You can say there is no solution. Now as you're working with these problems and you keep practicing, another way to say no solution is a circle with a line through it. So have either of those down for example 1. So example 2. We want to first say, okay, we want our equation solved for 0. We want to set it equal to 0. So we already have that, so that's good. The second step, we need to replace 0 with f of x. So let's rewrite that. Negative 3x plus 2 equal to f of x. And it's f of x is the same thing as y, so don't be thrown off by that. So y, or f of x, equals negative 3x plus 2. So now we want to graph that line. So y equals negative 3x plus 2. This plus 2 is like the b, that is our y-intercept. We've done y equals mx plus b a lot. And the number attached to x, we know that's m, that is our slope. So it has a y-intercept of 2, so that tells me to go 1, 2. And it has a slope of a negative 3. So from here, I can go down 1, 2, 3, and over 1. So my line will go through these points. And now if I draw my line through the graph, it's going to look something like this. Now what we need to know is at what point does our graph cross the x-axis? What is this value of x? Well, once we graph it, we see it's between 0 and 1. And if you want to double check with algebra, you can actually solve this thing for x. So if you solve that for x to double check, you could subtract 2 from both sides, and you would have negative 3x equals negative 2. If you divide both sides by negative 3, x would equal, this is a 3, x would equal positive 2/3. So that is the 0 for this graph. This point right here between 0 and 1 is actually 2/3. So we solved it in our 0. Where does it cross the x-axis? That intercept here is 2/3. Now here's another one we can try. The point here is to solve these by graphing. So let's move everything to the left. So if I subtract 3x from both sides, I want to get rid of that. These cancel out. So I have 2 equals a negative 1. If I add 1 to both sides, I know we're going to have 3 equals 0. So the second step then, once we did that, is to change the 0 to an f of x. So I can just say f of x equals 3. This is the same thing as y equals 3. We know the line y equals 3 is going to go up to 3, so here we are. And y equals is always a flat line. So imagine this is a flat line going across. So that flat line we have there. So where does this line cross the x-axis? Well, the answer is it doesn't. So there's no solution to this one. No solution for example 3. There's no 0. There's no point where that line crosses the x-axis. That's what we're looking for. Okay, fourth example. We want to do the same thing. So move everything to the left side. Get rid of the 4x through subtraction. So this goes away. This also goes away. If we subtract 2 from both sides, we'll get a negative 3 equals 0. The second step, once we do that, is to change the 0 to an f of x. So we know that our function, since we're using the variable x, is equal to a negative 3. So that is y equals negative 3. We know that's a flat line where y is negative 3. So 1, 2, 3 spots negative. And then we draw that line horizontally. Good, so we have that down. Now the next question is, where does this line cross the x-axis? And we've seen by now that if you have a flat line that's not on the x-axis, there is no solution. It does not cross. So this, example 4, also no solution. So have this image down to help you as we go through these. Okay, fifth example. So we're helped out because we see that everything's already on the left side, so we don't have to do any juggling around. So we can just change the 0 to f of x. So if I rewrite this, and I want to just put f of x first just because I can. So f of x is equal to this 4x minus 1. F of x equals 4x, take away 1. Now we want to graph this and see where does it cross our x-axis. That's going to give us the value that we want to find. So we know we want to normally look at lines. We like to have them in the form y equals slope times x plus some number. So given we understand that equation, the slope is a number attached to x, so the slope here is 4. The y-intercept is a number added on at the end, so the number added on at the end here is a -1. That's my y-intercept. So where does it cross the y-axis? I go to -1 right here. My slope is 4, so from here I can go up 4. 1, 2, 3, 4, and over 1. So I get this point right here. Now from there I can use these two lines to draw my graph. Those 2 points, excuse me. So I'll draw an arrow, and we know it's going to go through here, just like that. Good. So what is this value going to be? Well, we see that it's between 0 and 1, so we know it's going to be a fraction. So that's that 0. By graphing, we know we've graphed it, and we know that this 0, this x-intercept, is going to be between 0 and 1. So a way we can find the exact value is to now solve for x and what we're given. So 4x minus 1 equals 0. We can add 1 to both sides, and 4x equals 1. If we divide both sides by 4, what do we get? X, this cancels out, x equals 1/4. So if you're really precise with your graph, you'd be able to tell that this is 1/4. If not, you could use algebra to solve it. So that x value, where our line crosses, that x-intercept, we solve this expression, it is 1/4. So we know we can do algebra to solve this, but you can also graph it and get the same value. So that's the whole point. Now example 6. We're helped out because we already have it solved for 0. So change the 0 to f of x and graph it. So function evaluated for x equals everything on the right. So 5x plus 3. So my y-intercept is 3. 1, 2, 3. And my slope is 5. So we would go 1, 2, 3, 4, 5. And back 1. So double check, I go up 5 over 1. So these 2 points are right. So now I can draw my line through these points, just like that. Now we see our value is between 0 and -1, so we should get a negative number. And that value is going to be -3/5 for x. You can go back here and check by doing a little algebra if you'd like. But if you graph it accurately, you can see x is this fraction here. That is this solved, or when you graph it, that's this point here. So that's it for example 6. Have that down. 7th one, also solve for 0, so that helps. So change the 0 to f of x. And we see f of x equals -2x plus 4. Now the 4 represents what thing here? 4 is the b value, or our y-intercept. -2 is going to be our slope. So we'll go up to 4. 1, 2, 3, 4. And now we'll do what the slope says. It's a -2. So remembering slope is change in y over change in x. How do we change in y? We go back 2, and everything is written over 1. So from here we go down 2 over 1. You could repeat that to help you keep your line straight. So you get all those points there, and you can then draw your line. There we go, good. So where does this line cross the x-axis? The x-intercept is at 2. So this one's nice and easy because it's a whole number. X equals 2. And we are done on example 7. Now the 8th example today, we're going to have to do some work to get our everything moved to the left side. So first, I know I want this 3x gone. So I'll add the opposite to both sides. So what happens here? These go away. They cancel out. On the left, these also cancel out. So we're left with 8 equals 5. Now we know 8 equals 5 isn't a true statement, but we still want to move everything to the left. So subtracting 5 from both sides would allow me to get the next step. Here this becomes 0. And on the left we get 8 minus 5, which we know is 3. So 3 equals 0. Now we need to change the 0 to f of x. So f of x equals 3. Now remember we said f of x means the same thing as y. So we're used to using y a lot. Means the same thing. So y equals 3. What do we know about those kinds of lines? We know they are horizontal. So we go up 1, 2, 3, and then we draw our line, keep it horizontal, and leave it right there on your graph. Now we know doing these problems, the answer is wherever your line that you drew crosses the x-axis. So where does this cross? And we've seen this a few times today. We know that since it does not, there is no solution to this problem. So example 8, when you do some algebra, change it, graph it, the answer gives you nothing. No solution will work. You can also use the null set symbol there. So that is example 8. As we move on, have that image ready for your notes. Okay, 9th example. It's solved for 0, so that helps. We want to then change the 0 to f of x. So rewriting this, I will have f of x. That's when I replace. It's equal to negative x plus 1. Now, we have that whole thing. We know we can graph this. And what do I know about these values? Well, I know the number in front of x is my slope. And I know the number added at the end is my y-intercept. So my slope is a negative 1. There's an invisible 1 there. It's just 1x. So my slope is a negative 1. And it crosses the y-axis at positive 1. So y-axis, up and down, positive 1 right here. And my slope, I know, is a negative 1. So we will now take this point, and from here we'll go down 1 and over 1. Down 1, over 1. We could repeat that and know that our line is going to go across this way and up this way. So if I just put my arrow here, I know it's going to come down just like this. Alright, so given this, we know the solution when we graph will be where this line crosses our horizontal axis, our x-axis, which is horizontal. So what value is that? Well, it's at when x is 1. So that tells us our solution is x equals 1. Of course, you can always go back and check by solving this for x. So if you added x to both sides, you would have 1 equals x, which we know is the same thing we just said. So that checks out. X equals 1 is our solution given the graph for example 9. So have that image and the answer as we move to the 10th example. So these ones are going to require your attention. So please focus on these steps. Otherwise, it's going to be very difficult for you to understand this on a quiz, on a test in the future for the rest of the year and our time together. So please focus on this example. So we have a word problem to touch on. I'll read that shortly. So it tells us we're talking about gift cards. We know we're going to receive a gift card for trading cards from a local store. Our function is given here. So let's circle what is important. These are the kind of strategies that are useful when you have these kinds of problems on a test or on your homework, right? Take out what's important. So this is our function that tells us the number of dollars left on your gift card after you get some number of packages of cards. So every pack of cards you buy costs you money. It costs you $1.95. We're using the variable c to represent that. And they ask us to find the zero of the function. In other words, find out how many packages of cards you'd have to buy until you would run out of money, when you would have $0 left. Of course, we also know this term zero in a graph means where it crosses the x-axis. So that is our x-intercept. So find the zero. Describe what it means in this context. So let's just find both intercepts, and that will give us everything we need to know. So our y-intercept is where x is 0. So our y value, they're using different letters, it's the same idea though. So instead of x and y, we're using d and c. So our y-intercept, or in this case our d-intercept, will be when the other one is 0, when c is 0. So plugging in a 0 for c will tell me what value on this line my graph will be. So going to my equation, d equals 20 minus, and now I want to plug in a 0 for c. So 1.95 times 0, what will I get? 1.95 times 0 is just 0. So d will equal 20, and that's all. So that is the intercept, the d-intercept or the y-intercept. So that's going to be up here at 20. So that's 1 point for our graph. Now to find the other one, we want to find the x-intercept. In other words, the c-intercept for this problem. So where will this cross on this line? To find that, on that axis, we need to find out where d is 0. So let's plug in a 0 for d and solve it for c. So if we say d is 0 and we leave the rest the same, we need to know what is the number of packs of cards we could buy, and that would make us run out of money. So let's first, we know we want to get everything that's around the c away because we want to solve for it. So let's get rid of the 20 by subtracting. We have to do it to both sides. So this will cancel out. And on the left, we're going to get a negative number. So what do we see? Here, minus that, we get a negative 20 equals negative 1.95 times c. Now we know we want c alone, and we just want one c, not any numbers attached to it. So how do we get rid of this? We have to divide it away. Keeping track of the negatives, we'll end up with, this will all go away, so we just get 1c. And over here, we're going to get a positive number, because a negative divided by a negative is in fact a positive. So c will equal 20 divided by 1.95, and we have to keep in mind that this will be a positive number. So if we divide this, and you can check this in a calculator, c will equal 10 and about a quarter, about 0.25. And this is an exact, so these should be wavy equal signs here. So the amount of cards you could buy is about 10 and a quarter packs. So where will our graph cross here? Just a smidge above 10, right there. So if we were going to graph this, we would want to connect from here to there. So it should look just like that. Now the zero of the function is what value of x, where do we cross our x-axis? So it's at 10.25 like we said right here. That's our zero. The second thing to ask us is quickly describe what this means in the context. So it means we can buy 10 packs of cards, but we can't buy 11. Because if we bought any more than 10, the next one up would be 11. We don't have enough money for that. This indicates how much money we have left. You can see as we buy 7, we have a little. 8, we have a little less. 9, we have barely. 10, we're holding on to a few cents. If we tried to buy an 11th one, we have no more money left. So what does this mean in the context? We can only buy 10 packs and no more. So we can only buy 10 packs. So this is our intercept. That's our zero. And we know we can only buy 10 packs based on the context of this problem. So hopefully you feel confident with this material, and we can jump into some practice.